Good day, ladies and gents. All right, so today we're going to be doing Unit 3 study guide. It used to be Unit 4, but we are basically doing triangles. Awesome. All right, so let me just fix this a little bit. Let's see. All right, so a couple things that you guys need to have. One very helpful thing would be your hot topics, and I'll zoom out just in case you want to get a screenshot of that. Let me focus. So here is the top of that, and here's the bottom. Another thing that might help you guys out is all of these are the steps steps to keep in mind when you guys are doing what's it called, the proofs on proving triangles are congruent, yes or no. And there's nice little pictures to help you guys out. All right, sweet. So with this lovely information, let's just get started. All right, so zooming in here. All right, number one. All right, in order to prove that triangles are classified by their angles, they are equal angular, acute, right, and obtuse. That's how you prove classify by the angles. In order to classify by the sides, that is equilateral, isosceles, and scalene. So just move that over a little bit. Sweet. So equilateral, not equal angular, equilateral, isosceles, and scalene. So we have those right there. All right, so I'll zoom in so we can focus on this a little better. All right, so these are the basic ways on how to prove stuff. So I'm going to get my highlighters to help you focus, and I'm going to go from light to dark. So let's see. The first one says ABE. So here's ABE. So focus on that triangle right there. So they said to classify by the angles, then the sides. All right, in order to classify by the angles, so look at all these angles right here. One of these angles is 90 degrees, so that makes it a right triangle. So it's a right triangle, and that was specified by angle A. So that's very helpful. And I like to underline the letter that made that decision for us. Also, all of the sides are different, so that would make that scalene. All right, next, I'm going to go for green this time. And they said CDF. CDF. So that's that triangle right there. So focused on the green this time. So we did yellow a second ago, and now we're going to be doing green. Just help me stay a little organized here. So CDF. Based off the angles, I can tell that by this corner right here, so using the corner of my paper, I know that F is bigger than the corner of my paper, so that means that's bigger than 90 degrees. So that's greater than a 90-degree angle. So if that's greater than 90-degree angle, it's an obtuse triangle. And that decision was made by letter F. So I like to underline angle F. And then all the sides are different, so that would be scalene. All right, excellent. And then let's go for blue this time. DEF. So DEF, that's this triangle right here. All right, so looking at this, now I know for a fact that all of the angles are less than 90 degrees. So this is acute, but there's a better choice. Notice that all the sides are equal. If all the sides are equal, then all of the angles also have to be equal. So all of these angles also have to be 60 degrees because they have to add up to 180. If they're all the same, they would all have to be 60. So the better answer would be equal angular. And if it's equal angular, it's automatically equilateral as well. So all the angles are equal, all the sides are equal. So it's equal angular and equilateral. And those are the answers for that one. All right, number 4. So number 4, it says find the range of the third side if the two sides are 14. So I'll change that to numbers. So 14 and 20. So if we look at our hot topics, we know that the range of the third side, you subtract the two numbers, you add the two numbers. Now this right here, this is the absolute value. That means they're always going to be positive. So if we do this, that's the absolute value of 14 minus 20. Which is less than x, which is less than 14 plus 20. I like to show my calculator. I use this big hunky calculator right here, just so you can see all of my steps. So 14 minus 20 is a negative 6, but the absolute value here always gives me the positive. So that would mean 6. is less than x, which is less than 14 plus 20, and we get 34. So this right here is 34, and that is our range. So 6 is less than x, which is less than 34, and that's our answer. All right, so now number 5. All right, so on number 5 here, the best thing you can do is when they give you coordinates is to graph them. So -2, 5, I have no idea what's going on yet, just plotting these points. So there's my A, 3, -3, that's my B, and -4, -1, that is my C. And I use my straight edge to graph the lines to make the triangle, trying to be as exact as possible. All right, so there is my triangle, and they said to classify by the sides. So make sure you classify by the sides. In order to classify by the sides, we actually have to know what those distances are. So one way how to do this is to actually do the Pythagorean theorem. So we're going to make a right triangle. So making a right triangle here, we have that this right here, A to C, that is, you always start from the point and go towards the corner. So that's 1, 2, so that's 2 hops. By, and now if you go from here to here, you might stop too soon. So you always start at the dot. So 1, 2, 3, 4, 5, 6. So that's 6 squared equals x squared. And I want you to be able to follow my steps. So I'd like to show my calculator while I do this. All right, so we have 2 squared, which is 4. We have 6 squared, which is 36. 4 plus 36, we get 40. Is equal to x squared. That's a square root of 40. And just leave it like that. Don't reinvent the wheel. Just leave it as the square root of 40. And our lives will be that much simpler. All right, so that right there, that distance right there is a square root of 40. All right, let's do it again. And I only draw the triangles as I'm working on them. So that will just keep me organized. All right, so on this one, start at the dot. That's 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 squared plus 1, 2, 3, 4, 5. 5 squared equals x squared. So we got 8 squared. We have 5 squared. So we got 64 and 25 equals x squared. 64 plus 25, we get 89 equals x squared. We got the square root of 89 is equal to x. And I ran out of room, so I'll put it over here. So this one right here. Always start at the dot. So if you start at the corner and go, you might accidentally stop too early. So always start at the dot. 1, 2, 3, 4, 5, 6, 7. So that's 7 squared plus 1, 2. 2 squared equals x squared. So 7 squared and 2 squared, we get 49 plus 4 equals x squared. 49 plus 4, we get 53 equals x squared. So we got the square root of 53. So we got the square root of 53 on that one. All right, so our list so far. So from least to greatest, we have the square root of 40, we have the square root of 53, and you have the square root of 89 from least to greatest. So are all of those the same? Are they all different? How many sides are equal? None of them are equal. So if none are equal, so if no sides are equal, that would be scaling. That would be scaling. Now, what if I had asked you to to classify this by the angles? Just in case you were curious, if I said to classify by the angles on this one, remember how we got 40, 53, 89? So if I said classify by the angles, you would have to know how does c squared compare to a squared plus b squared. So if they're all equal, it would be equilateral. If it was c squared was less than, it would be acute. If it was equal, it would be right. And if it's greater than, it's obtuse. In this case, so you see the radicals and the squares cross out, you would get 89 is less than 93. So this would be a acute triangle, just in case you were curious. All right, moving on up. All right, so now number 6. For number 6, so we're trying to see small to large. So here's the basic rules. You would put the numbers in order, then you would give me the letter or letters I go with and tell me what the missing was. So in this case, see how 3 is the smallest side? That's B to C. And what's missing? A. So the smallest side was projected by the smallest angle, and vice versa. If they didn't give you all the angles, you would find the third missing angle. 75, 45 would be missing, make 180 would be 60. So let's say 45 is the smallest angle. So 45, 60, 75 from small to great. 45 is the smallest angle. That came with angle O, just the letter O. And then what was missing? M and O. So the smallest angle projected the smallest side. So let's go ahead and do some examples. All right, so zoom in just a little more here. So we're going to list this from least to greatest. So our numbers are 10, 20, and 22. Now 10 came with HI, 20 came with IG, and 22 came with GH. Now, those are my letters. What's missing? If I have H and I, what's missing is the letter G. IG, what's missing? H. GH, what's missing? I. And so this is the small, medium, large. And now all we have to do is put that in here. We said H was the medium, I was the large, and G was the small. And you're done. Okay, next one. Now, what if we have this? We have 52 is Z, Y is 90 degrees. But we're still missing one of those angles, right? Well, I know for a fact that X plus Y plus Z equals 180. So X, I don't know what that is. Y is 90 and Z was 52 equals 180. So I'll zoom out so you can see my calculator here. So if I take my calculator, I know 180, if I subtract the 90 and that 52, my X would have to be 38. All right, so at this moment, we know that X is 38, we know Y is 90, and we know that Z is 52. Let's zoom in here. All right, so let's get this started. So from least to greatest, we have 38, 52, and 90. So once we find the angle, we just reset. So 38, 52, 90. So 38 was X. 52 was not the Y, it was actually the Z. And 90 was the Y. And what's missing? If I have X, Y, Z is missing. Z, X, Y is missing. And Y, X, Z is missing. So this is the small, the medium, the large. So let's see. X, Y. X, Y is the medium. Y, Z is the small. And X, Z is the large. And those are your answers. Wonderful. All right, let's go ahead and go to number 8. So on number 8, okay, so let's go ahead and take all this information and put it into the picture. So they said DE is 5x plus 2. They said DF is 2x plus 3. And they said EF was 3x. Now, are these angles, which add up to 180, or are they sides? Well, these are all sides, so this has nothing to do with 180 degrees. So I go ahead and cross that out. In addition to that, they also said that the perimeter of triangle ABC is 50. So we know perimeter of the small versus perimeter of the big. Now, ABC, is that the big one or is that the small one? So ABC is the big one. And the small one would be triangle DEF. So in this case, they said ABC. In this case, that is the big one, is 50. So if that's 50, what would be the small one? Well, the small one would be half of that, so that'd be 25. So at this moment, we know that all of these, which is a small one, adds up to 25. So let's go ahead and do that. We know 5x plus 2 plus 2x plus 3 plus 3x equals 25. I'll show my calculator so you can see what's going on my head. Very dangerous place to be. All right, so we have 5 and 2 and 3. Those add up to 10x. We have 2 plus 3, and that's 5. All that is equal to 25. I subtract 5 from both sides. I get 10x is equal to 20. And then you take that 10x, we divide both sides by 10, we get x equals 2. So 20 divided by 10, and we get 2. All right, as soon as you get x, I've trained you guys to always put it back in here. So if we put that back in here, we get 5 times 2 plus 2, and this would be 12. 2 times 2 plus 3 would be 7, and 3 times 2 is 6. Now let's see if the equation's happy. So 12 plus 7 plus 6, does that equal 25? Let's see. Does 12 plus 7 plus 6, does that equal 25? Yes, it does. So I know for a fact that this is correct. All right. So let's put this in the picture. So putting this back in, we knew that a 5x plus 2, that is really a 12. We know that 2x plus 3 was a 7, and we know 3x was a 6. Grab my highlighter here. If all this is 12, then all of this right down here, from here all the way to here, would be 24. And this would be 12, and this would be 12. That's how that works. All right, let's try green this time. Okay, from here to here, those two are parallel. So if this right here is 6, then all of this is 12. So this be 6 and this be 6. And then let's do blue this time. All right, if I do blue, this side and this side, those are parallel. If this right here was 7, then all of this right here, from here to here, would have to be 14, and this would be 7, and this would be 7. So now I should be able to answer all their questions. I'm going to put this little thing here to help me focus a little better. All right, first of all, was x 13.5? No, x was definitely 2, so that's not true. X was 2. Yes, that's true. C to B. Here's C, here's B. All of that from C to B was 14. That's true. A to C. Here's A, here's C. All of that was 12. That's true. C to E. Here's C, here's E. That's 7. Oops, they said it was 6. That's false. A to B. Here's A, here's B. That's all this distance. We said that's 24. That's what they said as well. Boom. D to E. Here's D, here's E. That's 12. Ooh, they said 14. So that doesn't work. And finally, E to F. Here's E, here's F. That's 6. They said it was 12. So these are the things that are true. So I'll zoom out just in case you want to look at that again. And there you go. All right, let's keep going. All right, so now we're on number 9. All right, so for number 9 here, we know that the 3 angles of a triangle, so boom, so A, B, C. So we know that all those angles, A, B, and C, and let me actually draw this a little better. A, B, C, all those add up to 180 degrees. We also know that A, B, C, and D. We also know that A plus B would equal D, or better yet, A plus B equals the outside of C. So knowing these rules here, these 3 angles add up to 180 degrees, right? So all those add up to 180. Let's just do that. All right, so we have 8x minus 35 plus 6x minus 5 plus 3x minus 1 is equal to 180 degrees. So I'll show my calculator so you can see what's going on in my head. All right, so let's put that together. So we know 8, 6, and 3, who are all x's, that's 7x. And then we have negative 35 plus a negative 5 plus a negative 1 makes negative 41 is equal to 180 degrees. Okay, take that 180. I'm going to add 41 to both sides. And you get 17x is equal to 221. I take 221, divide that by 17, and I get x equals 13. All right, and once you get that, you always plug it back in, right? So always plug that sucker back in. So we had 8 times 13 minus that 35. Now we get that this is 69. And then 6 times 13 minus 5, that's 73. 3 times 13 minus 1, that's 38. And when you add those together, does it make the equation happy? Does 69 plus 73 plus 38 equal 180? Yes, it does. So I know for a fact that I'm correct, and my x was 13. Fabulous. All right, next one. All right, so this one right here, we know that this plus this equals the outside of that. So we have 5x minus 11 plus 2x plus 20 is equal to 11x minus 63. All right, so let's do our work. All right, 5 and 2 go together. We get 7x. Negative 11 plus 20, we get plus 9 is equal to 11x minus 63. I'm going to subtract 11x from both sides. So 7 minus that 11, I get negative 4x plus 9 is equal to negative 63. Negative 63, I'm going to subtract that 9. I get negative 4x is equal to negative 72. I ran out of room, so I'll put it up here. So I have negative 4x equals negative 72. I'm going to divide both sides by negative 4. Whoops, let's try again. Negative 72 divided by negative 4, and I get x equals 18. Whoops, only helps if you can see it. All right, so I divide that, and I get this number. Okay, so you always take this, and you plug it back into the equation, right? So let's plug that back in. We said... Okay, so 5 times 18 minus that 11, we get 79. 2 times 18 plus 20, that's 56. Okay, there's supposed to be a plus sign equals 11 times 18 minus 63, 135. So is this equation happy? Does 79 plus 56, I wonder if I can zoom in a little more. Nah, we're good. Is equal to 30. Yes. So everything checked out. So I know that this is correct. Now, if I put this back in the picture, I know that this right here was 56. This right here was 79. This right here is 135. And 180 subtract that 79 and that 56, I'd be left with 45 right here. And does 45 and 35 make 180 degrees? Yes, they do. So I'm like super solid that this is correct. So my x was 18. All right, you guys are doing great. Keep copying notes. All right, let's go to number 11. All right, so number 11 here. Okay, so I'm going to show more work than I need to so you can see what's going on in my head, so you can follow this pretty easily. So here we go. All right, so this right here makes a straight line. We're trying to get to the x over here. So this makes a straight line. If this is 120, and they make 180 degrees right here. So 180, subtract that 120, this angle right here would have to be 60 degrees. All right, so that's great so far. Now, in addition to that, if I turn this, these two arms are equal. That means my elbows, this elbow and this elbow would have to be equal to each other as well. Now, I don't want to call it x because x is already being used. So I'm going to call this A and A. So I know that... I'll just turn this normal. I know that all three of these add up to 180 degrees. So I know that 60 plus A equals 180. So if I take 180, so that's 60 plus 2A equals 180. If I subtract 60, 2A equals 120. If you divide by 2, A equals 60. So each one of these angles is really 60 and 60. All right, next. Right here, these are vertical angles. So this is vertical, which means that this angle and this angle would have to be equal to each other, and vice versa. This angle equals this angle. So if this is 60, this would also be 60. In addition to that, if I turn this sideways, here are my arms, my elbows be equal. So I'm going to put doubles on this. Boom, boom. So this angle and this equal to this angle. So if this is 60, then this would also be 60. Sorry, I'll put that in black so you can see that better. So that's 60, and that's 60. Oh, look, there's vertical angles again. So that would also have to be 60. Excellent. So this angle X is 60. All right, let's keep going. All right, over here, if I turn this, I know for a fact that if these arms are equal, my elbows are equal. So this angle equals this angle right here. So if this is 65, this would also have to be 65. And I'm trying to find this one right here. I know, so let's call that A. So 65 plus 65 plus A is equal to 180. 65 and 65 make 130 so far. If I subtract that 130, my angle A, so 180 minus 130, I would get A is 50. So this angle right here is really 50. And then these are vertical again. So if that's 50, this would also be 50. And then we have our elbows. So if these two arms are equal, then my elbows are equal. So if this is 50, this would also be 50. So I'll put doubles here and doubles here. So if this is 50, then this is also 50. And we also know that 50 plus that third angle, x, would equal 180. That's 100 so far. Equals 180. X would have to be 80 degrees. So that would have to be 80. Remember, I show more work than I need to. As long as you're labeling the picture, I'm happy with that. All right, fabulous. All right, let's keep going. Number 13. So number 13, the best way to do this would just be see what matches everything. So my this triangle right here, I'm going to make that my yellow triangle. And I'll just leave this as my white triangle. So for my yellow triangle, my first angle is Q, so that's angle 1. Angle 2 is P, and angle 3 is R. And those are my yellow triangles. That's my yellow triangle angles. All right, and that, what does that match to? Okay, so Q was angle 1. What was also angle 1? T. P was angle 2. My other angle 2 was U. And R is my angle 3. What was my other angle 3? That was S. So PQR, that's yellow. PQR, that's yellow. And RPQ, that's also yellow. So basically I'm taking all my yellows and I'm changing them into white. So they're changing into triangles. So it was a triangle before, it would still be a triangle. P turned into T. I'm sorry, I meant Q. Q turns into T. P turns into U, and R is the third letter, turns into S. And you just keep going. P turns into U, Q turns into T, and R turns into S. And finally, R turns into S, P turns into U, and Q turns into T. And those are the answers. All right, number 14. All right, so number 14, the best thing you can do to do this one is just take this statement and change them into to two triangles. So big triangle there and a big triangle there. All right, so I always like to go over the hill. Okay, so so I go from left to right over the hill. So they said W, X, Y, and that would match up with, in the same positions, H, J, I. All right, now take all this information and put it in here. They said from W to X, so that'd be this one right here, is 15. And then X is 114. And X to Y is 16. In addition to that, they said H was 37. So now we're just going to match everything. So both of these sides are 15. Both of these sides are 16. This angle right here is 114. And this angle right here is 37. All right, hopefully we have enough information. They said J to I, that would be 16. J to H is 15. Angle W is 37. Angle J is 114. And angle I, I need to go find angle I. I know that these three right here add up to 180. So if they have to add up to 180, so let's show my calculator here. I'm taking my calculator, I do 180, I subtract the 114 and the 37, and this angle right here would have to be 29. So what was angle I? 29. And we're done with that problem. And Y would also be 29 because it would be the same angle. All right, move it up. So now let's go to the next page. Okay, we are now on number 15. All right, so number 15, how do we prove the triangles are congruent? So basically, every combination except for these naughty words. So ASS and SSA, and your booty's so big it's AAA. So AA, those are bad ones. Every other combination is good. So we have so SSS, SAS, ASA, AAS, which is the same thing as SAA, and then we're not allowed to have this. So that'd be hypotenuse leg. So those would be all the combinations. All right. So when we travel around the triangles, okay, on this one, what do you have more of, angles or sides? I have more angles. So I'm going to start at the third angle I don't have. Now go in a circle, and I get angle 1, side 1, angle 2. And if I go around this one as well, I get angle 1, side 1, angle 2. I got the same exact thing. So ASA is the answer. All right, this one. I only have 2 bits of information. I need another one. So reflex property, 1, 2, 3. If I go around this, I get, so this one right here be side 1, 2, and 3. Side 1, side 2, side 3. Make sure the other one's the same thing. Side 1, 2, and 3. Yep, side 1, 2, and 3. And yes, SSS does work. All right, this one. I only have 2 bits of information. I need a third. So let's see. I know vertical angles. Boop, boop. All right, so what do you have more of, angles or sides? I have more sides marked equal. So start here, go in a circle. If I go in a circle, I get side 1, side 2, angle 1. Side 1, side 2, angle 1. If I start here and go in a circle, I get side 1, side 2, angle 1. Side 1, side 2, angle 1. All right, they're exactly the same, which is awesome. However, they spell SSA or ASS, depending which way. And the only time you can have ASS is if you have a leg. Is this a right triangle? No, it's not. So ASS is bad, and it's not hypotenuse leg. So this is a no. This is not congruent. All right, this one. What do you have more of, angles or sides? Sides. So I'd start at the third side. I go around, and I get angle 90, side 2, and side 1. This one, I get the exact same thing. Angle 90, side 2, side 1. Okay, they match, which is awesome. However, ASS is bad. When's the only time you can have ASS? When you have a leg. Is this a right triangle? Yes, it is. So this is really hypotenuse leg. So we're okay. And that's the answer to that one. All right, this one right here. Ooh, I like these ones. All right, so this right here, we have 2 sides. 1, 2. But we need a third side. So we're missing a side. So this is definitely gone because that's an angle. And this is definitely gone, which is an angle. It's between these two. So BX is equal to XC. So that looks legit. BX is equal to CX. Well, that's the same side. One of these is the better choice. Which one's better? Does BX match up with XC or does it match up with CX? This is the better choice. Because see how we went from the outs, so from the single side to the double, this would be from the single side to the double. So that would be the better choice from here to here. Awesome. All right, this one. We have 2 sides, so we're missing an angle. So this is gone and this is gone because we want angles are equal. Now the angles have to be between the 2 sides. So here are the 2 sides. So it has to be this angle is equal to this angle. That's what we want. Well, the center letter here is A, the center letter is D. That looks legit. The center letter here is B. The center letter here is C. That's definitely not right. So there was only one choice on that one, and the answer is B. I feel really solid about that. All right, next. All right, number 19. Okay, so don't overthink this. Basically, they told you everything that works, so you just have to give me the reasons. All right, so let's just go through it. They said Q is a midpoint of these things, and that was given to us. No confusion. Now, this would be the first thing. And they also said it was also this. That's the second thing. So this would have to be the first. This would have to be the second. So PQ is equal to TQ. That was from the first one because of midpoint. So definition of midpoint. RQ, boop, boop, is equal to SQ, boop, boop. And that also has to be from the definition of midpoint. All right, so now we took care of both things. Then they said Q is equal to Q. boop, boop. And those are angles. What kind of angles are those? Those are vertical angles. So those are vertical angles. And finally, why would the two triangles be equal? All right, what do you have more of, angles or sides? We have more sides. So start the third side you don't have. When you travel around, you get side 1, angle 1, side 2. Angle 1, side 2. And the other one would be the exact same thing. That's SAS. SAS. Now be careful. I see ASA, and a lot of people put that by accident. And then where the heck is the SA? Oh, it's over here. Those tricky buggers. They put it way over here. So be careful with that. All right, so and those are all the answers. Okay, we're getting closer. All right, number 20. Number 20, let's see. The given. Well, the only thing that they gave us was AC bisects angle BAD. That's the first thing it did. And angle BAC. That was the second thing it did. So right after that would have to be the first thing they cut and then the second thing they cut. All right. So they said angle A would be equal to, well, what would be the other angle right here? It would be, so they said BAC. Well, what matches up with B? D. So it would be angle DAC. Okay, and then in addition to that, they said BCA, that's the center letter C. So this angle, boop, boop, is equal to, and that would be the bottom angle. So they said BCA, that would be DCA. So angle DCA. So we took care of both those things. Then they said reflexive property. The only reflexive property on here is right here. So AC equals AC. And finally, always the last thing you're trying to do is what you're trying to prove. So triangle ABC is equal to triangle ADC. Prove is never a reason. Prove is never a reason. So why were triangles congruent? Well, when you travel around this, what do you have more of, angles or sides? I have more angles. So start at the third angle you don't have. Go in a circle, I get angle 1, side 1, angle 2. So angle 1, side 1, angle 2. So that'd be ASA. ASA would be your best answer. All right, number 21. Okay, so we know that that these two triangles are right triangles. So that's the first thing they said. So that was given. What was the other given? The other given was WX equals YX. All right, as soon as they say things are equal, mark it up. So WX, boop, is equal to YX. Boop. Then they said ZX. I said XZ is equal to XZ. Here's XZ, boop, boop. How do we know that? What kind of sides are those? That's reflexive. And then they said triangle is equal to triangle. So because triangle equals triangle, your only choices for triangle being equal to triangle are these right here. There's no other choice. So anytime I'm saying triangle equals triangle, it's going to be one of these. If you put anything else, you're not thinking. So when I travel around triangle, what do I have more of, angles or sides? I have more sides. So if I start here, I get angle 90, side 2, side 1. So angle 90, side 2, side 1. Ooh, that spells the naughty word, ASS. When's the only time you can have ASS? Is if you have a leg. So is this a right triangle? Yes, it is. So this is really hypotenuse leg. That's a better choice. Always the last thing you're trying to do is what you were trying to prove. So we were trying to prove that angle WXZ is equal to angle YXZ. And if you have to go an extra step, once you prove triangles are equal, all extra things, corresponding parts, that would be CPCTC. So CPCTC. All right, now for this. All right, so for the bottom here, which is all the logic stuff, here's the basic information. So if you need to take a picture of that, go for it. So if A, then B. So contra is you switch it and you put in the word not. So if not B, then not A. Converse is you just switch, if B, then A. Inverse, you put in the words not. So if not A, then not B. This little symbol right here means and. So you would have to have that this needs to be true and this needs to be true in order to be true. This little symbol means or. So basically, as long as one of them is true, it still works. This little symbol means if then, so just like this. So if A, then B, that's what that means. And then this, if it goes back, forward and backwards, that's an if and only if. So that's by conditional. So they both have to be true in order to work. So if and only if, right? Okay, so these are all of our choices. Okay, let's see. So number 22. So choose a conjecture that describes the seventh term. All right, the best way to do this is make a list of all 7 terms. So we have 1, 2, 3, 4, 5, 6, 7. All right, so the first term was 4, then 20, then 36, and then 52. So let's try to figure out how did we get from one thing to the other. So using my calculator here, trying to figure out what's going on. So there we go. All right, so trying to figure out what's going on. So how did I get from 4 to 20? All right, well, one way to get from 4 to 20 is by multiplying by 5. Let's see. If I multiply by 5, I would get 20. If I multiply by 5 again, so I take 20, I multiply by 5 again, ooh, I get 100. Did I land on what I was supposed to? No, that didn't work. So multiplying by 5 doesn't work. So what's another way? So 4, if I add 16, I get 20. So let's see, add 16. If I add 16 again, I get 36. That works so far. Add 16, I get 52. Okay, I think I figured it out. So let's just keep adding 16. I get 68. Add 16, I get 84, and add 16, I would get 100. Okay, so add 16 is what I need to do. Now, which one best describes that? Okay, multiply 52 by 9. None of this is saying add 16, is it? But I know for a fact I want 100. So let's see which one of these work. 52 multiplied by 9, I get 468. Is that what I want? No, I wanted 100, so that doesn't work. Okay, 52 times 16. Nope, that's 832. I want 100, so that doesn't work. 32, add that to 52. I get 84. Nope, I wanted 100. And then 48 plus 52. There we go. We get 100. That's the thing I wanted. I don't quite understand what's going on here, but I knew for a fact I needed 100. So that's the answer. So at the very least, I was like, it's between C and D because that has an 84 as well. But D was the better answer. All right, moving up. All right, number 23. All right, so for number 23, okay. Okay, so remembering all these rules here that we talked about. So 23, if 3 points are non-collinear. So let's see. So if that's my A, then this would be my B. So that's my A, that's my B, right? So this is my A, this is my B. All right, and we're trying to match this up, right? So trying to figure this out. Which one is these? So I'm just going to highlight anything that has anything about with collinear stuff in it. So this is collinear, collinear, collinear. And then my green with anything about points on a plane. So plane, plane, plane. All right, so let's see. And then, so let's figure out what they're talking about. Okay, so first of all, I know for a fact that this is B, then A. And this is A and B, and that is B and A. All right, so now my A is supposed to be non-collinear. This is definitely non-collinear. That says collinear, so that this changed. So that one changed. And then this one says collinear, so that one changed as well. So those are the knots, right? And then for my B's, my B is supposed to be define a plane. So 3 points on a plane, yep. Not on a plane, so that changed. And then this one right here, not on a plane, so that changed. All right, so basically, this went, so this one just switched. So this one just switched, so that would have to be converse. So that one switched, so that's converse. This one stayed the same, but it put in the word knots in both of them. So I inverse those because I put in the word not. And then this one switched and put in the word not. So that would be contrapositive. All right, so I feel really solid about that. All right, so, and then, okay, number 24. Okay, 24. Write a definition of biconditional statement. So that's if then statement, or sorry, if and only if. So a rectangle is a parallelogram with 4 right angles. So I think the best way to say this is it is a parallelogram if and only if. So a parallelogram is a rectangle if and only if it has 4 right angles. So a parallelogram is a rectangle if and only if it has 4 right angles. There we go. So as long as you put the if then statement somewhere in there, you're pretty much good. All right. Statements. Okay, so statement 1 and statement 2 are true conditional statements. So if a figure is a parallelogram, then it is a quadrilateral. That's statement 1. Statement 2, if the figure is a quadrilateral, then it has the angles sum up to 360. Which one is a valid? All right, so let's see here. So that's A, B, C, and D. All right, so this one, if a just looking at my list here. All right, so in this case, we have if a figure is a quadrilateral. So let's talk about that for a second. So if a figure is a quadrilateral. So a quadrilateral is a 4-sided shape. Can everyone agree with that? And then so 4-sided, so quadrilateral 4-sided shape. So if a figure is a 4-sided shape, then it is a parallelogram. Okay, I can make a 4-sided shape that's not a parallelogram. So here's a 4-sided shape, and this is not a parallelogram. A parallelogram, by the way, is where all the sides are parallel. So this is a 4-sided shape, but it's not parallel, so that's false. So that didn't work. A figure is not a parallelogram, so this is not a parallelogram. Then the angles don't add up to 360. Okay, all these do add up to 360, so that's false, because I could think of a counterexample. If a figure A angles sum up to 360, all these add up to 360, they already do, then the figure is a parallelogram. Okay, just because they add up 360 did not make this a parallelogram. This is still not a parallelogram. And then if a figure is a parallelogram, okay, so if we have this, so there's my parallelogram, then this angles out of 360. Okay, there's no way around that, so we're stuck with that one. So D is the only one that works. And finally, number 26. All right, so 26. So basically over here, as long as you can think of one thing that does not work, it's false. All right, consider these two. A square is a quadrilateral, and a trapezoid is a parallelogram. So here's your list. All right, so these little symbols right here, so I just went ahead and made this. All right, so P is a square is a quadrilateral. That's a 4-sided shape, so that's true. And then if this little symbol means not, so a square is not a quadrilateral. That's false. A square is a, so there we go. Q says a trapezoid, which is that symbol, is a parallelogram. That's false. It's not a parallelogram. The sides are only one set of sides parallel. We need both sides. Okay, and then a trapezoid is not a parallelogram. That's true. So if we go down our list of all those symbols, so if I put in the word knots and stuff like that, then these would be the statements. Okay, square is not a quadrilateral, so that is false. A square is a quadrilateral, so that was false. Okay, trapezoid is not a parallelogram. That's true, because it's not. Now this says a square is a quad, and that's what the symbol means, and a trapezoid is a parallelogram. Okay, a square is a quadrilateral. That's true, and a trapezoid is a parallelogram. That's false. Both of these need to be true in order for this to work. So true and false makes false. A square is a quadrilateral. That's true. Or a trapezoid is parallelogram. That's false. So only one of these had to be true for this to work. So that was true. This one, a square is not a quadrilateral. That's false. And or the trapezoid is a parallelogram. That's false or false. Okay, both falses make false. And finally, a square is a quadrilateral. That's true. And a trapezoid is not a parallelogram. That's true. True and true make true. So with those choices, which ones worked? So with those choices right there, we know that the things that are true are B, D, and F. And that's everything. So hopefully that helped you guys out. And that right there is the end of the study guide. Have a great and wonderful day.